All right, everybody, we are back in Unit 4 and we are doing Lesson 1, which is on reflections. A reflection is basically when you take a figure and flip it across something. So it's not a slide, it is actually like a pancake. You're making a pancake, you stick the spatula underneath, you pick it up, you flip it over. That's a reflection. It says use rigid motions to reflect figures on the coordinate plane and describe the effects of the reflections. Well, first off, you don't even know what a rigid motion is. We need to talk about that. A rigid motion is, well, basically anything except a dilation. It's when you keep the same size and shape of the figure. You either move it, flip it, turn it. You just don't make it grow or shrink in size. So it's definitely not a dilation. All right, looks like we got an online activity. It says use dynamic geometry software to complete the Explorer. I have no idea what that means, but I like using GeoGebra. So I've got my GeoGebra pulled up in case I need it. And with reflections, I'm probably going to need it. All right, so let's see. Reflection in a vertical line. Well, vertical line is a line that goes up and down. Let's see what it says. When a figure is reflected in a vertical line that is not the y-axis, the y-coordinates in the image remain the same as the pre-image. Okay, first off, a pre-image is the original figure. An image is the one that's reflected. It's the one that you've done something to. All right. Reflection across the horizontal. When the figure is reflected in a horizontal line is not the x-axis, the coordinates of the image remain the same as the pre-image. Right. Distance goes through all that. Okay. And then reflection across the line of y equals x. All you do is just switch their coordinates. I don't know if you guys remember back in the other unit we were talking about reflections. So I'm going to go through not only the examples in here, I'm going to go and remind you of the x-axis. If I get my words out, x-axis, y-axis, and origin as well. Okay, so let's get into this. Example number 1, reflection in a horizontal or vertical line. Consider quad RSTV with vertices RS21, S24, T54, and V53. Graph the image, all right, that's your original figure, of quadrilateral RSTV under each reflection. I'm sorry, the image is the one you're doing to. This is your pre-image. I apologize. I did say that backwards. Determine the coordinates of the image. Okay, so this is my pre-image, and I'm going to flip it across y equals -1 to get my image. All right, determine the coordinates of the image. Okay, well, first off, if you're a visual person, I'm going to open up my GeoGebra and put these ordered pairs in. The 2-1, the 2-4, the 5-4, and the 5-3. So, yeah, here goes. All right, R is 2-1. S is 2-4, and T is 5-4, so 2-4, 5-4. And last but not least, V is 5-3. And I'm going to go ahead and connect them to make it look like this little trapezoid thing I've got going on here. So V is 5-3. All right. I'm going to connect it with a polygon. So I'm going to go to the 5th icon over, click on polygon, and I'm going to connect one right after the other to make this trapezoid looking shape. All right, first off, I know it's a trapezoid because SR, TV are parallel lines, and the other one's TV, and sorry, I can even speak today apparently. ST and RV are not. As you'll notice, GeoGebra gives me the distance of all of these. So the distance from S to T was 6. As you can see, and it just goes around. All right. So I need to draw my line y equals -1. This is a horizontal line at -1. All right, there it is. Y is -1, and it's horizontal. Now they want me to reflect across this. Well, for you visual people, what the distance is above for R must be the exact same distance below for R prime. So my new R prime is going to be right there because R is 2 above the line of reflection. That's what we call the line we're flipping over. And the new R prime, it looks like an R with a tick mark, is going to be 2 below. So I'm going to put an R right here. I'm going to move R. I guess I just did it wrong. Let me undo this. All right, 2 above, 2 below. There we go. And change this to R prime. S is 1, 2, 3, 4, 5 above. The new S will be 1, 2, 3, 4, 5 below. V is 1, 2, 3, 4 above. My new V will be 1, 2, 3, 4 below. I'm literally just counting blocks. D, 1, 2, 3, 4, 5 above. The new one is 1, 2, 3, 4, 5 below. Now, for you guys that know GeoGebra, you probably know that I'm going to show you a shortcut. But yeah, there we go. I'm going to connect that to make a polygon. And you'll notice that there it's the exact same figure. I have just flipped it over. So this straight ST that is at the top is now at the bottom. And then this sloped line, RV, that was on the bottom of the figure is now on the top. So it just flips over. So like I said, there is, of course, a shortcut to this. So I'm going to get rid of all of these points that I created and renamed. And here's your shortcut. Go to this little icon where you see a blue and red dot as a reflection over a line and click this. I want to reflect about a line. That means I'm going to flip it over a line. So I'm going to click there and see how it says select the object. Now, don't select just one of the points. I mean, literally select the polygon. The entire thing lights up. Now you're going to select the line you want to flip over. And when you hit enter, boom, you got it. All right, so there is the exact same figure that I made manually. This figure actually does it for you. So that's what your example down here, part A, is going to look like. All right, so R prime. And if you don't feel like going, okay, right 2, down 3, remember they will give me these ordered pairs. So it looks like R prime is down 2. Sorry, right 2, down 3. I mean, I can't say anything right today. What is my problem? I guess I'm just tired. So 2, -3. Been a long day at school. That's going to be my excuse. All right, S prime is 2, -6. T prime is 5, -6. Last but not least, B prime, 5, -5. 5, -5, B prime. All right. Looks like we are done with that one. All right, let's do the next one. So it looks like it's the same figure. This time I'm going to reflect it across the x equals -2. This is a vertical line, x, because that's the axis it crosses. So I'm going to back up till I get my original figure. There's my original. And this time I want to draw a vertical line at -2, going up and down. And you'll notice last time that I actually just put the equation in over here. But I just want you guys to see that if I actually draw it myself, that it can still flip across. So there it is, x equals -2. So this time I just drew it, and it gave me the equation over there. All right, so shortcut. If you're looking for one, and for visual people, click on the figure, click on the line, and of course I'm going to move this over so you guys can see it, but they're the same distance away. So your original S was 1, 2, 3, 4 on the right side of the line of reflection. The new S, which is S prime, 1, 2, 3, 4 on the left. So they are equidistant. That means equal distances away from the line that you're reflecting over. Again, it's called the line of reflection. And for you shortcut people over here are your ordered pairs. All right. So you're more than welcome to, after you graph that, is to count over and then up. So I'm going left 6, which is negative, up 1, and that's why it's a -6, 1 for R prime. All right, if you want to cheat it, it's over here, -6, 4. But that's going to be from the origin, left 6, up 4, -6, 4. All right. T is left 9, up 4. That's a -9, 4. B prime, B prime, left 9, up 3. So it's going to be a -9, 3. All right, looks like I'm done with example number 1. Looks like there's an online for another extra example if you want to do that, or if your teacher assigns it to you. All right, we're going to keep on going with this check down here. All right, we got a triangle BCD that has coordinates B, C, and D. All right, select the coordinate of the vertices of the image after reflection across x equals 3. Well, you know what? I could probably do this without actually graphing it, because x equals 3 is a vertical line. All right, vertical 1, 2, 3. So this vertical line is going to up and down right here. Now they only want, no, they want all of them. But okay, well, I got you a shortcut. Watch this. If this is the line x equals 3, and I've already told you that C and C prime are going to be equal distances away from this line of reflection, and my line is right here. If C is 2 to the left of this line, C prime is going to be 2 to the right of this prime. So we've got to find the ordered pair for this dot that's sitting right here. Remember, if this is your line of reflection, which is the vertical line, x equals 3, if your pre-image is 2 to the left, for C, your image for the C is going to be 2 to the right. So I'm looking for the order pair of this right here. So just count over. 1, 2, 3, 4, 5. Up 1, 2, 3, 4. So your C prime is going to be 5, 4. Not it. Not it. Possibly it. Not it. There it is. There's your answer. And of course, you want to do GeoGebra. Yeah, you can do that. Pull it up. Example number 2. All right, we have reflection across the line y equals x. And it looks like they gave me both the pre-image and image, the original and the new. All right, Winona is designing a logo for her blog header. She graphs a figure on the coordinate plane and wants to reflect it in the line y equals x to complete the basic shape for her logo design. This is this line right here, y equals x. What are the coordinates of the vertices of the image after each reflection? All right, well, here's your shortcut, you guys. This is what I call a cheat code. You know how students, if they get stuck on a video game, they will look up cheat codes. Yes, why I call it a cheat code. X and Y literally switch places. So if A is negative 2, 1, A prime will be 1, negative 2. Okay, what is going on here? And if I make it bigger or smaller, something's going on with this. Okay, I'll just go with it. Yeah, this is messed up. I won't be able to get them all in. Yeah, I'm not sure why this is messed up. B being 1, 8 would be 8, 1. Looks like that one's done for me. Can't see it though. C, 1, 4. Switching would be 4, 1. I guess, is that D? I think D is what this one is. Looks like E might be done for me. All right, so switch them. D, 4, 4. Well, that doesn't change. 4, 4. Probably because it's on the line. Yeah, D's on the line, so the D prime would stay on the line. It's not going to jump off the line if it was on there originally. So I'm not sure why mine is messed up. I apologize for that. All right, the check, the landscape. Thomas is designing a sculpture garden for an art museum. There is a sidewalk connecting the center of the museum entrance to the edge of the lawn. I'm assuming that's it right there. Thomas has a set of 4 sculptures in the series that he wants to be equidistant from the sidewalk. Okay, so basically it looks like he's going to take Q and reflect it over, and X and reflect it over. If pieces Q and R are a pair, all right, so that's saying is when I take Q and flip it over, it's going to become an R. X and Y are a pair, so that means I'm going to take X, flip it over, and it's going to become a Y. Where will the pieces R and Y be placed in the garden? All right, well, you visual people. If I'm reflecting across this line, what is the same distance away from the line above will be the same distance away from the line below. So see how it's a diagonal from the line to Q? So diagonal up and to the left will be a diagonal down and to the right. So R is going to be right there, which is the ordered pair 3, 1. Possibly. Nope. 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 Just in case you want to do it with X, X is 1 diagonal away from the line. That means Y will be 1 diagonal below. So Y is going to be correct right there. That's 1, 2, 3, 4, up 2. There it is, verified, 4, 2. It looks like we've got another online activity. A couple of online activities for extra examples if you guys want to try that. All right, your practice is coming up, but I'm not going to cut the video off yet. I want to make sure you guys understand the reflection across the x-axis, y-axis, and origin. So you remember. So what I'm going to do is I'm going to take this figure, I'm going to reflect it across the x-axis because I want to remind you what changes in your ordered pairs. So my figure that's the pre-image is in quadrant 1, which means all of my ordered pairs are positive. But when I reflect across the x-axis, which ones become negative? Do you guys remember? Well, if I'm at the origin and I go right first, I'm still going positive. So it's not the x values that change. But because I go down to get to my new ordered pairs, it's the y value that changes. Over here, you guys can see that. R originally was 2, 1. To negative 1 is the change. My original S was 2, 4. S prime is 2, negative 4. So one more time, when you take a figure reflected across the x-axis, it is the y values that change. All right, now let's reflect it across the y-axis. So I'm going to click on my figure, click on the y-axis, and it flips over. Okay, so again, my pre-image positive for x and y, but now I'm sitting in quadrant 2, where to get over here, I have to go left before I go up. I went right before in my pre-image, which are my positive x values. But now I'm going left, which are my negative x values. Still going up over here. That means y is going to stay positive. So when reflecting across the y-axis, it's the x values that change this time. One more time, the original r was 2, 1. R prime is negative 2, 1. So the x values changed. The original s was 2, 4. S prime is negative 2, 4. So again, the x value changes when you flip across the y-axis. Origin. Now this time to flip across the origin, I have to have a dot right here. So I'm going to go to point. I'm going to put a point at the origin because I have to tell the computer what I want to flip across. And if there's nothing there, it won't do it. So I'm going to come back to reflect, but this time not reflect across the line. When I'm reflecting across the origin, I'm only reflecting across one point. So reflect about a point. Same thing though, I got to select the object and then the point, that's the center point. There it is. I reflected it across the origin. So I want you guys to kind of watch out what happened. R was right 2, up 1, positive and positive. Now R prime is left 2, down 1. So that's going to be negative and negative. So we are changing both from positive to negative. And if you're a visual person, I'll show you guys that. Our original R was 2, 1. Our new R, negative 2, negative 1. So they both changed. Our original S is 2, 4. Our S prime, negative 2, negative 4. So again, they both change when the figure is reflected or flipped across the origin. So I know that was back in the other unit, but I really feel like I needed to share that one more time because I really didn't talk about that in detail with my students because I knew we were going to have a whole chapter on this coming up. All right, well, that's it for me, for you guys on reflections. If you have any questions, ask your teacher or let me know. I'll be happy to help. All right, y'all, have a great afternoon.